So let us now look at the concept of compound events. So compound events are, it's very simple. Two or more events, when they occur together, then their joint occurrence is called compound event. So for instance, it's very simple. If I have a bag, which has some balls, maybe 5 red balls. So 1, 2, 3, 4, 5, 5 red balls and 6 white balls. 4, 5, 6. So these are the balls in this box. If I tell you that you're drawing a red ball and a black ball together, so you're drawing a red ball and you're drawing a black ball. So this event E is drawing a red ball and a black ball. So this is a combination of more than one event, right? So drawing a red ball is, it could be another event, and drawing a not a white ball, a black ball, not black ball, a white ball. Drawing a white ball could be another event. So you're taking a combination of these two events. So that you're taking a joint event in which you're drawing a red ball and a black ball. You're drawing both of them together, right? So such events are called as compound events, where more than one events are occurring at the same time. Now coming to this very, very important concept called conditional probability. This is very, very important. So basically, most of the chapters, most of the questions in this particular chapter are divided into 3 or 4 categories. The first is your normal addition theorem, which we saw. A lot of questions will fall under that. Basically, classical definition of probability. So definition of probability, that part. And then addition theorem, you'll have a lot of questions. Conditional probability, you'll have questions. We'll see Bayes theorem next, which will have questions. We'll have binomial distribution, which will have some questions, right? So 1, 2, 3, 4, and 5, and basically independent events, maybe more. So these 5, 6 broad categories, all the questions will, most of them will actually fall under one of these categories. So conditional probability is one of those. So it's important. So here, what do you mean by conditional probability? So I have two events A and B. I have two events A and B. Then the conditional probability of occurrence of the event A when B has already occurred, right, is denoted by this particular formula. So what does this mean? What does PA/B mean? It means occurrence of A when B has already occurred. So given that B has occurred, what are the chances of A? Right, so basically, given that already B has occurred, what are the chances of A? So let me take an example and explain you this. So let us take this example to understand what conditional probability is. So basically, if I have a dice and I roll it, what are the possible outcomes? I can get a 1, 2, 3, 4, 5, 6, right? Now I say my event B is getting an even number, and my event A is getting a prime number. So getting an even number, what are the cases? What does your n of b have? N of b has getting an even number. What are the even numbers here? 2, 4, and 6, right? And n of a getting your prime number. What are the possibilities? So 2 is a prime number, 3 is a prime number, and 5 is a prime number. So 2, 3, 5 are your possibilities. Now, if I ask you what is P of A/B, that means what is the probability of occurrence of A given that B has already occurred? Now, just instead of A and B, say this with me. What is the probability of getting a prime number given that an even number has already occurred? So, ultimately what I'm asking you is, what is the probability of getting a prime number which should be an even number? Because the even number constraint, the even number condition is already there. That's why it's called conditional probability. The even number condition is already imposed. Now what is the probability of getting a prime number, which is, and obviously it means getting a prime number which is an even number. That is the reason why P of A/B is basically having this formula, n of A intersection B by n of B. So now your sample space is B, right? Because B has already occurred. Whatever your favorable cases are, you have to pick them up from the set B, right? because B has already occurred, now you need to pick up those cases which are favorable and also in B, because B has already occurred. So cases which are favorable and also in B, that means both A and B, right? That's why you have N of A intersection B. So here if I look at this, what is my N of A intersection B? What is that prime number which is also an even number? That's 2, right? So 2. So this is basically N of A intersection B. N of A intersection B is the number of elements in A and B, and that is 1. The only element is 2, right? So only one element is there. Divided by number of elements in B are basically 3. So 1 by 3 is the answer. So if you have N of A intersection B divided by N of B, so you can always write this as N of A intersection B divided by N of S, this particular thing. If I divide with N of S in both numerator and denominator, and this was in the denominator, you have N of B by N of S. So N of A intersection B by N of S is probability of A intersection B, and N of B by N of S is probability of B, right? That is why you have this formula. Probability of A intersection B divided by probability of B. Remember this, it will be very useful. So I hope you understood the concept of what conditional probability is. Now you have to do tons and tons of problems on conditional probability to understand, how to actually use this particular formula. So that is the thing with probability, as I told you. There's not a lot of theory, there are not a lot of formulas. It's only about the application of those formula in different cases, so that you don't intermix cases. You know exactly about what the case is, what you need to pick up, which formula you need to use, and then calculations are very, very simple. So with this we complete conditional probability. Let's now move to the multiplication of probability, or the theorem of compound probability.